Hi everyone, my name is Frederico Machava. I am student of AIMS Rwanda. I'm doing my master in mathematical science. So I'm here to talk about my work in Statistical Machine Learning Course. So our task or our work is divided in three parts. For the first part, we have exercise one, when where in this exercise is to load CSV files and resolve some task from using this data set. But for exercise 2, we need to use one package from our studio that we call kernel lab. So in this package we can find all the data that we need to use to solve the exercise 2. And for the last part, I'm talking about the exercise 3, is to explain how I did this or how I solved exercise 1 and exercise 2 doing a video. So it's very important to explain that to solve or to plot all the graphics, I use RStudio on, and I use some function for RStudio. Example, I'm talking about ggplot, I'm talking about dim to know the size, and read CSV to load our data files and other things. So it's necessary to explain the first part. So I starting with the exploration of our data set. I download the CSV file contain relevant information. So I use for it R markdown, and I visualize the data, and using Ding, as I said, I can know the number of the rows and the number of the columns. And using functions, I plot this graphic. That is very important, because from this graphic we can understand very well the relationship between y versus x. So it's crucial for identifying partners or correlation in our data. So for the other part, to know the kind of our task, we look for our output, so we can see that our values look like real numbers, continuous numbers, so we can know that we are talking about the regression. And for the theoretical part, for function, I suggest polynomial. Why? Because when I look for my graph, look like it's not straight line, but look like a polynomial function. So in this reason, I choose this to explain. And for the all this part, to solve it, I use some books, I use some page from internet to get the information for this part. But when we're talking about our optimal model complexity, so I found using function I found that is 10. So I use graphs to compare training errors and cross validations error, and we can see from our graphics that as the model complexity increase, the train error decrease, but the validation error start to stabilize and eventually increase. So this indicates the risk of overfitting. And to know the significance of the difference between the models, I use ANOVA. So ANOVA is very important to know the significant difference between the models. So the result showed that the difference between the models was statistically significant. So we can see, as we can see for our value of p. Okay, so can do it. So for the second part, that we use kernel to get all information. Here we have some graphics, but for the second part, okay, so we can see from the distribution of our responsive that the dataset contains 4,061 observation and 58 variable. So we're talking about the very big data set with high dimensional and sparsity. So I identified something that is important to say here. First, the imbalanced data. Why? Because the non-span, as we can see, with this class domains which can introduce bias in the model. And other thing that I identify here is to need for normalization. So sparse variable require regularization or robust models such as tree-based model. So this is what we did in this task, and we plot here the graph to see in comparative all our curves. So thank you for watching the video. See you. Bye bye.